Hello everyone, welcome back to Mathfluence with Mr. L. In today's video, we're going to learn how to solve quadratic equations using quadratic formula. Right, so if you look at the left side of the screen here, you can see that I've got a box that will explain to us what is a quadratic formula and how to use it. So for ax squared plus bx plus c equal to 0, what we can do to find x is we can first identify the discriminant, okay, or sometimes we call it the delta, and the symbol for it is a triangle. So what we're going to do is we're going to have to do b squared, take b squared minus 4ac. So basically we take the coefficient in front of x, we square it, and we minus by 4 times the coefficient in front of x squared, which is a. Yep, so you can see it right there. Times the constant term, which is going to be our c. Right, now, once you've done that, once you've done determine the discriminant or the delta, one of the three situations, well, one of the three cases might occur. So the first scenario is when you would have the discriminant being less than 0. Now, when the discriminant is less than 0, we would have 0 solutions. We have no x solutions. Actually, let me just quickly show you what it means. So let me just draw a Cartesian plane out. Right, so with this Cartesian plane, I would have my y-axis over here. This is my x-axis. This is my origins. No, so when we have a discriminant that is less than 0, basically what it means is that we would have a graph or the parabola, or the quadratic graph will look like this. Would either look like that, like that, like that, or like that, right? So there's many other different ways that we can draw this, but I'm just trying to explain to you that if you look at these graphs that we have over here, there's just no x-intercept between the parabola and the x-axis at all. So if you look at this parabola here, you can see that the parabola, even if you try to sketch the parabola outward and make it very big, you can see that there's no x-intercept whatsoever between the graph itself and the x-axis, same as these other three parabola as well. So that's when we have the discriminants less than 0, so there's no x-intercepts at all. So that's why we say there's no real x solutions, right? So what happened when we have the discriminant equal to 0? Why does it have one real solution? So when we have the discriminant equal to 0, the graph or the parabola of the quadratic equations basically looks something like this. Oops, that's a very bad drawing. I'll just redraw that. Okay, will look something like that. So why is that? So if you look at this parabola here, you can see that the parabola touches the x-axis at one point only. There's only one x-intercept. So that's why we have just the one real solutions at negative b over 2a. Alright, so what if we have the discriminants larger than 0? So the discriminants larger than 0, or otherwise is a positive number. So we would have two real solutions. So what does the graph of an equation like that would look like? So it will look something like this. Okay, it will look something like that, right? So if you look at it, you can see that the parabola here touches the x-axis at 2 points, and hence we have the two x-intercepts, hence we have two x values. Or it can even look like this. It can even look like that. And then we still have the two x-intercepts right there, or even something that looks like this. Okay, so we'd have the two x-intercept like right here and right here. Right, so that's how we get that. That's what it means to have the discriminant larger than 0, equal to 0, and less than 0. Let's go ahead and try to solve for some example and just to really see how can we use it in actual questions. Okay. Alright, so you can see this is my first example, so we just have to simply solve for x. So clearly this is a quadratic equation because the highest degree of this equation is a squared. So what we're going to do is we're going to just to follow this box that we have over here on our left. So the first thing that we do, let me just write it down, solution. The first thing that we do when we're trying to solve for the quadratic equation using the quadratic formula, the good thing about using the quadratic formula is that we can use the quadratic formula to solve almost, I think, we can solve it for, we can use it to solve every quadratic equations out there. All right, so sometime we can use the null factor law or completing the square to try to solve for the quadratic equation, but those techniques are not always going to work. However, with the quadratic formula, it will always work. Right, so the first step that you do is to find the delta or the discriminant. So the first thing you would do is to find the discriminant, which is equal to b squared minus 4ac. Right, so your b squared is going to be your 5 squared because b is the coefficient in front of x, which is 5, and then it's minus 4 times a. So a is the coefficient in front of x squared, which is 1. So a times 1 times c, which is going to be 9, and then we will have 25 minus 4 times 1 times 9 is 36. Alright, so 25 minus 36 is going to be negative 11. So therefore, we can just conclude the questions that there is no real solution. Okay? So when you are given one question, one of these questions where you just immediately found that, okay, well, the discriminant is less than 0, okay, so you can just jump right to the conclusion saying there's no real solution, and then your job is done. Okay, let's have a look at another example. Alright, so here we have the next example, which is 9x squared minus 30x plus 25 equal to 0. So the first thing that we do is also to determine the discriminant, so solution. So what we do is to find the discriminant, which is b squared minus 4ac. It's actually worth it if you try to remember this quadratic formula off by heart, because sometimes it's just a lot easier for you to try to solve this question without trying to flicking through the pages of the book or trying too hard when you couldn't work it out using the other techniques. Right, so b squared minus 4ac, what we have is going to be the coefficient in front of x is negative 30, so I'm going to have negative 30 all squared, right? And I would have minus 4 times a, which is going to be times 9, and then times c, which is going to be times 25. All right, so if you do that, right, if you put this whole thing into the calculator, you would get the answer of 0. Okay, 30 squared is 900. 4 times 9 times 25 is also 900. Okay, so once we have the discriminants equal to 0, so we can just conclude that there is one real solutions. There is one real solution. Now, because there's one real solution, that means we can only have one x value, right? And the x value is going to be at x, actually. One real solution at, let's write it here, x equals to negative b over 2a. Okay, so your b is negative 30. So negative b is going to be negative 30 on the inside of the bracket over 2a, which is going to be 2 times 9. Okay, so that would be 30 over 18. Okay, and if you simplify that, that would be 5 over 3. Okay, so your final answer would be 5 over 3. Okay, so that's how you would solve when the quadratic equations when you have the discriminant equal to 0. Let's go on ahead and try some other example. Alright, so here I have another example. So it is 2x squared plus 5x minus 1 equal to 0. Now we try to solve for x. So the first thing we do is to determine the discriminant. And just to see how many different solutions do we have. So the discriminant is once again equal to b squared minus 4ac. Alright, so your b, which is the coefficient in front of x, is going to be 5 and then squared, minus 4 times a, which is times 2, times c, which is going to times negative 1. Right, so if we do that, we will have the discriminant equal to 12. Alright, now if the discriminant is equal to 12, therefore it's larger than 0, therefore we can just conclude that there are two real solutions. Okay, now once you've gotten to the state where you just determine that, okay, we got two real solutions because the discriminant is larger than 0, right? Then once we've got that, you will go back to this formula over here. We've got two x values. One of them is negative b plus the square root of delta over 2a, and one of them is negative b minus the square root of delta over 2a. So the only difference between these two x1 and x2 value is really the plus and the minus in between negative b and the square root of delta. So what we're going to do is we're going to go ahead and try to solve it. So we would have, alright, x1. So what I would do x1 equals to negative b plus the square root of delta, or the square root of the discriminant over 2a, which is going to be equal to negative b, which is negative 5, plus the square root of 12 over 2a, which is 2 times 2. So therefore we would have negative 5 plus the square root of 12 over 4. So that is your first x solutions, okay, x1, and your x2 is very simple. We just go x2 equals to negative b. Now the first x we already have plus the discriminant, so the square root of the discriminant. So all we need to do is to do minus, right? Minus the discriminant over 2a. So what we're going to have is negative 5 minus square root of 12 over 4. Okay. Oops, sorry, over 2 times 2, I'll just do it the same as the top. Then negative 5 minus square root of 12 over 4. Now I've seen some people try to simplify the surd. For me, when you get to this sort of the solutions of x1 and x2 like this, I would be really happy with it. But some people, they might like to simplify the surd, which is going to be negative 5 plus 2 root 3. Yep, so simplify the surd over 4. And then negative 5 minus 2 root 3 over 4. Now, if you get to this point here, okay, for me, I think that is good enough. That is the final answer already. So you do not need to go any further than that. But if you go ahead and just go above and beyond, and then sort of just simplify the surd, that's awesome. Okay. Now let's try another one before we go. Alright, so here we have another example. The example is x squared plus 4x equals to 1. So it might not look as straightforward as the example that we've been doing so far, because it doesn't come in this form here, ax squared plus bx plus c equal to 0. But all we need to do is just to rearrange it a little bit. Right, so what we're going to do is I'm going to go write solutions. We just first want to rearrange the equation so that it's going to look like ax squared plus bx plus c equal to 0. So what we have is ax squared is x squared stay the same, plus bx, which is going to be my 4x, and then you see how we got the 1 over here. So what we're going to do is we're going to have to move it to the left hand side, so this becomes a minus 1, and then the right hand side would just be 0. Okay, so now that we've got the form of ax squared plus bx minus plus bx plus c equals to 0 already, all we need to do is to continue with the step that we've been doing for the last 3 questions. So delta, or the discriminant, is equal to b squared minus 4ac. Okay, my b is going to be number 4, so 4 squared minus 4 times a, which is times 1, and then times c, which is going to be times negative 1. Alright, and then you would have 16 negative 4 times 1 times negative 1 is going to be a plus 4, and therefore your delta would be 20. Right, so what you're going to do is you're going to just go ahead and conclude that there are 2 real solutions. There are 2 solutions. 2 real or 2, you can just say 2 real or 2 rational solutions. It doesn't matter in this case. So there are 2 real solutions. So 2 real solutions. Okay. There are 2 real solutions. Right, so the first solutions, which is your x1, going to be equals to negative b. We just have to follow the formula that we've got over here. You see that? This formula. So negative b plus the square root of the discriminant, which is 20. We're going to replace that later. So negative b plus the square root of the discriminant over 2a. So negative b, which is going to be negative 4. Alright, plus the square root of 20. Okay, plus the square root of 20. Okay, and over 2a, which is going to be 2 times 1. Alright, so you can have negative 4 plus the square root of 20 over 2. So I would be happy with that answer there, but if you want to go ahead and sort of just simplify the surd, what you would have is negative 4 plus 2 root 5, okay, over 2. Right, then we got x squared, sorry, not x squared, my bad, x2, or the second x value, is at negative b minus square root of delta over 2a. Same thing happens here. We got negative 4, but instead of having a plus, we will have a minus square root of 20, and then over 2 times 1, and then we would have negative 4 minus square root of 20 over 2. Right, or we can even go above and beyond and do negative 4 minus 2 root 5 over 2. Okay, well, one thing that worth noticing is that I see a lot of students, they do this. So when they get this sort of answer here, right, they just put it into the calculator and try to round it to 2 decimal places or to 1 decimal place. Now, it's very important that you give the answer in the exact value, right? Give them an exact value unless otherwise it's specified to you that you need to round it to 2 decimal places or 1 decimal places or whatever significant figures that they want. right? So it's unless the question tells you what to do, always leave your answer in the exact form. Okay, we always want the exact answer, especially in math, as well, in mathematics and math specialists. All right, so that's it for this video. I hope that I have helped you a little bit in terms of understanding how to solve the quadratic equation using the quadratic formula. Okay, if you like the video, please leave a like and subscribe, and stay tuned for more video. Bye.